What if I told you that somewhere in the universe, hidden in the very laws of physics, there exists a substance more powerful than anything we've ever created? A substance so strange that a speck of it, no bigger than a grain of sand, could release the energy of an atomic bomb. A substance that has the power to both destroy worlds and one day, perhaps, take us to the stars. This isn't a plot from science fiction. This is antimatter. And the mystery of antimatter may hold the key to understanding why the universe exists at all. So what exactly is antimatter? And why does it sound like the universe's most dangerous secret? To answer that, we need to step back and look at the building blocks of reality itself. Everything around you, the chair you're sitting on, the air you're breathing, your own body, is made of matter. Matter is built from tiny particles, protons, neutrons, and electrons. Now imagine a cosmic mirror. For every particle of matter, there exists a twin, a reflection. Identical in mass but opposite in charge. Electrons have their antimatter partner, the positron, with a positive charge. Protons have antiprotons, carrying the opposite electrical charge. Even neutrons, which seem neutral, have antimatter versions called antineutrons. Here's where things get really strange. When matter and antimatter meet, they don't just bump into each other. They vanish. They annihilate completely, releasing a burst of pure energy according to Einstein's famous equation E equals mc2. No leftover particles. No ash, no smoke, no debris. Just energy released in an instant. To put that into perspective, 1 gram of antimatter colliding with 1 gram of matter would release energy equivalent to about 40 kilotons of TNT. That's nearly 3 times the destructive power of the atomic bomb dropped on Hiroshima. And that's from something smaller than a sugar cube. But if antimatter is real and so powerful, why don't we see it around us? Why isn't the universe filled with it? This brings us to one of the biggest mysteries in modern physics. According to the Big Bang Theory, the universe should have been born with equal amounts of matter and antimatter. But if that had happened, every particle of matter would have immediately met its antimatter partner. The universe would have annihilated itself in the first fraction of a second, leaving behind nothing but pure radiation. And yet, here we are. A universe filled with galaxies, stars, planets, and us. Somehow, matter won the cosmic battle. There was just a tiny imbalance, maybe 1 extra particle of matter for every billion particles of antimatter. That tiny imbalance was enough to tip the scales, leaving behind the matter that makes up everything we see today. But why did this imbalance happen? Why did matter survive while antimatter disappeared? We don't know. This puzzle is called the matter-antimatter asymmetry problem, and solving it may reveal the ultimate secret of why anything exists at all. To search for answers, scientists look deep into the universe. Gamma ray bursts in distant galaxies. Strange signals from cosmic rays hitting Earth. Even the possibility that entire regions of space might be filled with antimatter stars and galaxies. So far, no clear evidence, but the hunt continues. Here on Earth, we can actually create antimatter. In fact, it's being made right now in some of the most advanced labs on the planet. Particle accelerators like CERN's Large Hadron Collider smash particles together at nearly the speed of light. In the chaos of those collisions, tiny amounts of antimatter appear, antiprotons, positrons, and more. But these particles exist only for fractions of a second before colliding with matter and annihilating again. And yet, we've learned how to trap some of it. Scientists use magnetic fields to hold antimatter in place, keeping it from touching the walls of its container. In 2011, researchers at CERN held atoms of antihydrogen for a record 1,000 seconds, about 17 minutes. It was a groundbreaking achievement, showing that antimatter can be studied and contained. But here's the catch. The amounts we create are unbelievably tiny. To make even 1 gram of antimatter would take billions of years at current production rates. And the cost? It would run into trillions of dollars. Right now, antimatter is the most expensive substance in existence. Despite these challenges, antimatter isn't just a scientific curiosity. It already has practical uses. Hospitals around the world use positrons in medical imaging. Positron emission tomography, or PET scans, allow doctors to see inside the human body with incredible detail, helping detect diseases like cancer. Without antimatter, this technology wouldn't exist. But what about the future? Could we ever use antimatter as fuel? Imagine a spacecraft powered by antimatter engines, capable of traveling across the solar system or even to other stars. Because antimatter releases energy with nearly 100% efficiency, it's the ultimate rocket fuel. No chemical engine, no nuclear reactor could come close. Science fiction often imagines starships fueled by antimatter streaking across the galaxy at unimaginable speeds. And in theory, it's possible. But the reality is, we're still far from that dream. The challenge of producing, storing, and safely handling antimatter is almost beyond imagination. And there's another side to the story. If antimatter can power starships, it could also create weapons more terrifying than anything humanity has ever seen. An antimatter bomb would make nuclear weapons look small by comparison. It's the kind of power that could wipe out entire cities in an instant. For now, thankfully, the technology doesn't exist to weaponize antimatter. But the possibility lingers, a reminder of the double-edged sword of scientific discovery. So where does that leave us? On one hand, antimatter is a symbol of danger, destruction, and unimaginable power. On the other, it represents hope, a key to solving the mysteries of the universe and perhaps one day unlocking the stars. Antimatter isn't just science fiction. It's real. It's here. It's hiding in the equations of physics, waiting for us to understand it. And maybe, just maybe, when humanity finally learns to master antimatter, it will mark the beginning of a new era. An era where we step beyond our tiny planet into the vast cosmos, powered by the very opposite of existence itself. So the next time you hear the word antimatter, remember this. It is both the greatest threat and the greatest opportunity the universe has ever given us.